Hello everyone, Mr. Fawcett here, and we are back for part 2 of our order of operations lesson. In our previous video, we did some of the easier practice problems as well as discussed the set order of operations, parentheses, exponents, multiplication and division, and addition and subtraction. However, in some of our practice problems, we talked about how those acronyms sometimes don't have to be followed as strictly as it may seem. So sometimes we're allowed to do some addition before like division, as long as we rewrite the expression appropriately so that we can do that addition. And then we also talked about some exponent rules and reviewed some things that you may not have seen since your last math course. Today we're going to get into some of the tougher problems. And as always, I encourage you to attempt them before you just watch the video and look at the answers and explanations. Even if you're not sure what to do at first or they look intimidating, give them a shot, break them down, piece them apart, right? You can work on pieces of the problem at a time, and then gradually you make the whole thing look a little bit easier. We are going to start with number 28. So I would pause the video and see if you can come up with a answer to the expression for 28. Okay, 28 has more going on than usual, and we're going to start with this inside parentheses right here. We're going to start with that quotient. So I'm going to rewrite everything else. I've got 9 on the outside, in parentheses. My numerator isn't going to change, that's 8. And I have minus 5 outside. Now, negative 2 cubed. This is something we talked about in last video. If I have an exponent, that is just telling me how many times I need to multiply the base by itself. So negative 2 cubed is equal to negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Then we still have one more negative 2, and that's going to be equal to negative 8. So again, you're free to do this work off to the side. It may be a little easier for you than just writing all those negative 2's inside our denominator here. But once we simplify that, we get negative 8. And now things are starting to look a little bit easier. My next line, I'm going to get 9. Inside parentheses, I'm going to get 8 divided by negative 8, which is negative 1 minus 5. Now, here I have no choice. I must perform my multiplication first before my subtraction. So 9 times negative 1 is negative 9 minus 5, and that is going to be equal to negative 14. So negative 14 would be our correct answer for number 28. All right, we are off and running to number 31. All right, 31 looks intimidating just because there's a bunch of fractions, but let's break it down piece by piece and see what we get. Of course, you should attempt this before you continue watching. Okay, so we're going to treat this the same way. We're going to think about our numerator and denominator. We're going to leave the negative 9 alone for now. And I think I'm going to start... No, I can just start on the white. I was going to think maybe I'd start off on the gray. That's okay. What I'm going to do is I'm going to simplify, or not simplify, but convert these mixed numbers to improper fractions. I know when you first start learning math, they teach you to convert improper fractions to mixed numbers. Like if you have 8/5, a lot of times they teach you to write that as 1 3/5. But in upper level math, as the level of your classes increases, we are more than okay with working with improper fractions. In fact, we kind of prefer it. It's going to be easier for you long term to work with the improper fractions than have to deal with the mixed numbers. The reason being is that when you have a mixed number, you have two parts to that number that you have to deal with when you're adding, subtracting, multiplying, dividing. When you have an improper fraction like this, there's just one part, whereas over here, there's two parts. There's the 1 and there's the 3/5. So if I convert these, it's going to make our lives a bit easier as we move forward. To convert mixed numbers to improper fractions, you multiply the number portion by the denominator and then add the numerator. So let's just do my example over here. If I have 2 and 3/5, that's going to give me 2 times 5, which is 10, plus 3, so 13/5. So over here, I do 9 times 5, which is 45, plus 8, which is 53, so 53/9. In my denominator, I get 3 times 4, which is 12, plus 3, which is 15, so 15/4 minus -9. Okay, so now we have this complex fraction. We have a fraction in the numerator, fraction in the denominator. The way we simplify these is that we think back to the rule, and I'm sure you've been exposed to it. I'm not sure how much time you spent on it. But if I'm dividing by a fraction, that's the same thing as multiplying by the reciprocal of that fraction. So let me do another example for you off to the side. If I have pen please, thank you. If I have 1/2 divided by 2/3, that is equal to 1/2 times the reciprocal of our denominator, so times 3/2. Reciprocal just means flip the numerator, flip the denominator. Once I write it like this, I just multiply straight across. So I get 3/4. So if we change this to a multiplication problem, it becomes easier to solve or to simplify. So this is going to be equal to, let's do purple, say 53/9 times the reciprocal of 15/4, so 4 divided by 15 minus -9. Let's get rid of what's in green. Now I've got some multiplication to do. So this is going to be equal to 53 times 4 is 212. And you would have access to a calculator here. If I was asking you to do something like this, you wouldn't have to do that in your head. 9 times 15 is 135. And then minus -9. I'm going to come up here. I'm going to change it to green so I can see a little better. So I have 212 over 135. And I'm just going to simplify this minus -9 part. That's just going to be plus 9, right? If I'm subtracting a negative, it's like adding. Now, if I want to add these two fractions, I need to find a common denominator. We could first try to simplify the fraction on the left. You could try to find a common factor between 212 and 135. Off the top of my head, I cannot think of one, but I could just be missing. Something. Let's say you can't find one. That means our common denominator is going to be 135. So we get 212 over 135 plus, now this number right here, 9, I need to multiply that by 135 divided by 135. So I need to multiply by something that is equal to 1, so it doesn't change the value of 9. Right? 135 over 135 is 1, and 9 times 1 is still 9. So I haven't changed anything. But this will give me a denominator of 135, because I'm going to multiply the 9 to the numerator, and the denominator is going to stay. So I'm going to get some big numbers here, and that's okay. 9 times 135 is 1,215. Numbers are big, but now I can at least add them. I can add my numerators together. So I get 1,427 divided by 135. And again, I'm not going to give you something like this that I expect you to simplify or I expect you to find a common factor for. If I expected you to find a common factor, I would give you numbers that are a lot smaller. So we will stop here for now. I'm more concerned about the process by which we got here rather than you being able to simplify a 4-digit number divided by a 3-digit number. Okay? Okay, that was a lot of work, but these are all steps that you've seen before. Maybe you haven't pieced them all together, but I'm confident that you've seen them at least individually. So now we're just working on putting them all together. And these last 10 problems are definitely going to take some practice to become proficient at, but it's what we need to do if we're going to become strong Algebra 1 students. Okay, we're moving on to, we're going to do 32 actually, so I don't have to move anywhere. Same thing as 31, I'm going to convert the mixed number to an improper fraction. So 2 times 6 is 12 plus 1 is 13, so 13/6 times 1/2 minus -1. I'm going to multiply my fractions together. So straight across, so I get 13/12. If I'm doing minus -1, that's just going to be equal to +1. Okay, so this one isn't too bad, right? 13/12. I'm going to multiply 1 by 12/12 to get that common denominator. So I get +12/12, which is equal, you know what, I'll just do it off to the side here so I don't run into those words, which is equal to 25/12. Okay, onward to 35. We'll try to keep this one shorter than, I know the last video was 25 minutes, which is a little long, but it was just a bunch of practice problems, so you could stop it at any time if you were confident with what you're doing. Okay, 35. Again, we see a mixed number. Going to convert it to an improper fraction first. It's inside parentheses, which is what I want to deal with first anyways. So my mixed number is 2 7/10. My improper fraction is going to be 10 times 2 plus 7. So 20 plus 7, which is 27. 27/10 squared minus 1/6. We are now going to, because we can't simplify what's inside of my parentheses, I'm going to apply the exponent. Remember, the exponent says multiply the base by itself a certain number of times. In this case, it's 2. Okay, I'm going to get some big numbers again, but do not let them worry you. You can use a calculator here. 27 times 27 gives us 729. 10 times 10 gives us 100. Then we have minus 1/6. I'm going to come up here. Again, we're only doing 35. We're not doing 36 right now. I need to find a common denominator. The easiest way to find a common denominator is just to multiply the denominators together. That may not give you the least common denominator, but it will give you a common denominator. So that's what I'm going to do here. So I'm going to multiply this fraction, so 729 over 100, by, let's use blue, by 6/6, because 6 was the denominator of 1/6. I'm going to multiply 1/6 by 100 over 100. Let's make that a little lighter so we can see it. Hopefully that's a little better. And now I just need to simplify. Again, large numbers here. So here is a trick to help you not have as large of a number. You can simplify. So I could simplify. I'm not sure if I want to do this in the middle. Actually, I'm going to do it at the end. I don't want to confuse you right now. So we're going to stay with where we're at. So 6 times 729 is 4,374. 6 times 100 is 600. Minus 1 times 100 is 100. 6 times 100 is 600. Then I can combine my fractions, so I get 4,274 divided by 600. It should be clear that these both share a factor of 2, so I can divide my numerator and my denominator by 2. And I'm going to be left with 2,137 divided by 300. And again, like I said, my goal is not to get you to have to simplify these large 4-digit numerators and 3-digit denominators. I simplified out a factor of 2 because they were both even, which is pretty obvious. But it's not very obvious if there's another common factor here between the two. So we will stick with this. Again, it's the process that I'm concerned about in these sets of videos. We can work on finding common factors at another point, but the order of operations is what we're concerned about right now. Okay, that is going to do it for this video. We're going to keep it right at about 17 minutes. These practice problems are probably going to take you a little bit longer, and you may come across some spots where you're just not sure what to do. That's a time to write down a question, but it's also a time to try to approach the problem in multiple ways and try another method if the first one doesn't seem to get you the answer that you need. So keep pushing at them, keep working through that productive struggle, and eventually we will come out on top. That's it for today's video. Enjoy the rest of your day, and I look forward to seeing you next time.